Coming back to the experiment now, this is the setup. That is the bulb, this is the motion detector, and that is where we're going to see the results. So what I'm going to start out is I'm going to give this a small displacement in the towards the detector as I made in my graphs. So small detector over here, and I'm going to start. Now here, as here you can see that since my displacements are very small, as done over there, the displacements are very small. You can see that the amplitude is not a lot. You can see it varies in the second decimal place over here. So you can see that it's the position is starting from below the mean point over here, and we can see that this is how the graph is looking. Now we can move on to see the velocity time graph. We can open the velocity time graph, set this to two graphs, and if I could zoom in over here, and now this you can see is the velocity time graph. I made some slight changes to the graph by zooming in, and you can see this is how the velocity is changing, exactly like how we predicted it to change over here. So as you can see that the graph that I have drawn and the graph that we see that has been produced, they are exactly the same. So we can conclude that that is how the velocity time and the position time graph changes. Now there are some other minor, Now we can see there are some other details that we can find out from here. That is the frequency, time period, and the amplitude. So if you look closely over here, the time period or the distance between two troughs, in this case we can see which is the best. Right, so now here we can see that this is one of the troughs or crests. We can see that that time 2.35 seconds. So that is when we're starting, 2.35 seconds to 2 seconds, and if we take the second reading, that is 3.5 seconds. Second reading is 3.5 seconds. So I'll start by subtracting this will give us our time period, capital T. So we do this on a calculator. This will give us a time period of 1.15 seconds. This is the time period. Going back to the what the amplitude will be. So again, the amplitude is half of the maximum minus the minimum displacement. So we can see that the minimum displacement is at this position, and it is 0.259 meters or and the maximum displacement is at this point, and it is 0.31 meters. Now after subtracting this, we will get our amplitude. So now after solving this, we will get the amplitude as this is actually twice the amplitude. So this will be 0.05. This is actually twice the amplitude.